Thanks for coming to my talk. Really happy to be here in Canberra to talk about two of my most favorite things in the world, gaming and Kubernetes. So my name is Jai. I'm from London, and a really big thank you to the organizer here at Geek Sessions and to GDE, the Google Developer Experts Program, for allowing me to come and give this session today. So I work for a company called Jellyfish. We work in branding and advertising. I'm a platform engineer / cloud architect. I do a bit of work around SRE and DevOps. And essentially what we do, especially in my team, we take analytics data from paid media platforms, push it into BigQuery, use some BigQuery Vertex AI models. Some of them are predefined, some of them are bespoke, get some analytics data, create some models, and then push that back into media platforms. So quite interesting, AI, but unfortunately my talk doesn't have any AI today. So if you like Kubernetes, you like gaming, this is going to be explore it with you. So the agenda, just very quickly, talk about Minecraft, Minetest. It's called Minetest. I was going to use Minecraft, but I wanted it to keep the spirit of open source. So there's an open source version of Minecraft called Minetest, really accessible, like for like, and you can run it almost anywhere. Talk about Agones, the game architecture, the environment configuration. I have a live demo, so please, fingers crossed, it all goes to plan. But again, it's a gaming environment running on Kubernetes. Excuse me. My girlfriend and my daughter say whenever I'm on stage, I hold the mic like a rapper, so I have to keep correcting myself. I'll run through the demo and then we'll have a Q&A. All right. So why talk about Minecraft? Why talk about Minetest? And for me, show my age now, it's nostalgia. I love old school gaming, 8-bit gaming. And I thought, why not mix the old with the new? And in the world of AI, I'm starting to think that Kubernetes is feeling a bit old. It's been around for 11 years, there's a lot of new technology coming out. But mixing the two of them I thought would be really interesting because gaming itself, the actual game platforms, and if you think about things like Call of Duty, Minecraft, and these kind of games, football, etc., you have millions of games, the environments are very complex. So what is Minecraft for those of you that don't know? Well, it's a vector-based game. You start off in a world like this. The worlds themselves are randomly generated, and they're called seeds. But essentially, you start in the world with nothing, with your hands and your imagination, and of course, time. The good thing about using Minecraft on this, or Minetest, is that you can turn the world from this into something like this, right? You create tools, you create recipes, you create all these different kind of inventions in the world. Again, you could do something like this by yourself, but the great thing about Minecraft is that it's a multiplayer game. So you could have like 15 of you in a team. You will see like player versus player, where you'll have different groups and they'll be combating in the world. Or they might just come together and collaborate and create a beautiful city like this. But similar to development work, it's got a lot of similarities, right? In that the only real limitation is time, money, your imagination, and some degree skill, but with AI, it's kind of easy to get for us all. So again, one of the big inspirations for me, and I've lost days, hours, weeks, months, hopefully not years in Minecraft worlds. But essentially this guy here, what he did was he was looking at the limitations with Minecraft. And with Java and mathematics, it reaches a limit where Java can't actually compute past a certain point, and the Minecraft world starts to crash and glitch in really weird ways. And traditionally when you had to run Minecraft or Minetest servers, it was in Java. So the memory limits often cause big limitations. And if you think about the world that I showed you previously, where it was really complex, it puts a lot of stress on the actual server. And if the user's playing the game, it gets really laggy, it starts to glitch, it starts to break. But Kubernetes helps take away the pain of this. If you're interested, if you go to YouTube, search Minecraft, the Farlands. If we look at the entertainment industry, music yearly, 13 billion generated, film, 32 billion generated, Television, which surprised me, was 82 billion generated. But the gaming skills are transferable. You could also always create a game, open source, or sell it on a marketplace. But it's very profitable and very complex, like I said before. So Kubernetes and Agones. Let's talk about the two infrastructure parts that are going to make this all possible. So Kubernetes is an orchestration platform. Google open sourced it some time ago. They had their version, which was called Borg, which a lot of Google's kind of underlying infrastructure still runs on. It's a more bespoke version, but they open sourced it. And Kubernetes is great for running lots of different types of applications. I've chose gaming, number one, because it's fun, but it's complex, but it shows the flexibility of the platform itself. Kubernetes has a rich ecosystem. So there's lots of companies that are using it, lots of developers, lots of engineers that are contributing and making Kubernetes better, updating the source code, updating the actual platform itself. And it has native features such as auto-scaling and auto-healing. So if you're thinking again about a really massively multiplayer game like FIFA, where concurrently there might be 1 million players all around the world playing at any one time, if you have your games running on Kubernetes, it will scale, it would also auto-fix and make it so that the latency, the response rate, the user experience is really good for your entire player base. And another great thing about Kubernetes, you can have your actual, we'll call them servers, but they're nodes, in different geographic locations. So if I'm a user connecting in the USA or in Portugal or in Brazil or in London, it will connect me to a game server that's closest to me, which makes it, again, a much better environment. So Agones. Agones is really cool. It's come from Greek, similar to Kubernetes, so there's a bit of parody in the naming there. But it's really good for Kubernetes, and let me just quickly say that it was co-developed with Google and Ubisoft. So Ubisoft is a game publisher. They run games like The Division, which is another multiplayer game, really profitable, runs on PlayStation. But a lot of large companies are using Kubernetes to run their games on. You can manage the game servers. It supports any game engine. Again, you have that full flexibility. You develop the game code, and then you can run it on Kubernetes. And in combination with Kubernetes and Agones, you can determine the orchestration and the availability of your game. Another cool thing is you get native metrics and monitoring through open sensors, which I will show you in the demo. And you get platform-independent monitoring dashboards. So similar to the talk at the beginning with the introduction from the sponsor, if you're using Elastic, Kibana, these kind of tools, you can surface all your metrics and so forth and work with it like that. So this is the Agones architecture. It's also the Kubernetes architecture. So for those of you, and I will quickly slide to this part here. Don't know if you can see at the back, but essentially you've got the game front end at the top. You've got the Agones control plane. The really cool thing about Agores is that it kind of augments Kubernetes. So even though it's an external platform within the ecosystem, it integrates natively with Kubernetes. So Kubernetes talks to and uses Agones as if it was a native feature within Kubernetes itself. So again, less on latency, less on complexity. And if you're familiar with Kubernetes, then you can use Agones as well. It sits on top, it has a control plane where, and I'll show you on the actual in Kubernetes itself, which manages the actual control like the player base and so forth. Then you have the Kubernetes control plane with Agones CRDs, which are the custom resource definitions. And they're the bits that take away the abstraction and integrate natively with Kubernetes. You have your game servers here, which you would declare, and I'll show you the configuration with that. And then the pods, which are like little Docker containers where your game code is actually running in. Then you've got the game runtime down here and the actual game client. There's a link at the bottom if you'd like to have a look at any more detail. So this is Minetest, inverted quotes, Minecraft architecture. And as you can see, we're not going to go into detail, and this is just more for illustration purposes. Games are very complex within themselves. There's a lot of moving parts. The game world, managing the players, the environments, the objects, how all the different pieces interact with each other. Think about the physics in games as well, the lighting systems. There's a lot happening, and it's all happening in real time. So as a game developer, as a game company, if you can rely and just focus on making the game really good, and then have a platform that can run the game with a lot less effort, it's going to make your experience a lot better. Checking on time. Okay. So Agones fleets. These are kind of like the magic that helps Kubernetes orchestrate these games. You have the game servers. The game servers, they support the underlying game. It's similar to a deployment where you kind of say to Kubernetes, I would like free pods or free game servers running in this region using this software. Make it happen for me. The fleets do that in such a way where game servers are different than fleets. Game servers are different than pods. So it allows Kubernetes to manage this environment in a scalable way. Again, native auto-scaling, load balancing, player allocation. Again, going back to when you want to load or when you want to log into a game that's close to you, the fleets and the game servers, they make that happen because they will look at the IP address where you're logging in from. And if it's from a geographical location that they understand, where you program it into the actual Kubernetes manifest, it will match you and put you on a game server that's close to you. So if you're in the USA, it's not going to put you in a game server in London, for example. And then you have multiple configure options that can be extended via CRDs. And you can use open source technologies. Again, having that flexibility without having to pay is going to open a lot of avenues for you, and it makes it very accessible. So this is an example of a game server. Essentially, it's the YAML file with the configuration. Configure the game server's port policy and container port up here. So essentially within the actual game server itself, I'm telling Kubernetes to expose UDP port 30,000 within the Kubernetes cluster so that the game pods can talk to each other within the environment. The image here is from Paul Kim. So this is the Docker container with the Minetest game wrapped up in a Docker container that you deploy into Kubernetes. But essentially, I'm telling Kubernetes here, this is my game server pod. This is the image. Deploy it into the cluster. Give it 1 gig of memory minimum and 4 gigs maximum. One of the things that I spoke to you about before with traditional Minecraft, and it's the same with Minetest, when you're running Java applications with the memory limits and so forth, you can get memory leaks and it will start to crash. So it's really important that you set the memory kind of limitations and quotas so that Kubernetes can kind of manage it if there's anything happening. This is the game server allocation. Very straightforward, very easy to kind of manipulate. But essentially, we're telling Kubernetes, I have a fleet of game servers, which is essentially a collection of game servers, manage them as a single unit. And what I will do, I will tag each and every of the game server pods with the label Minetest, so that when a new one comes into effect, Kubernetes knows how to allocate it and which network it needs to be put on. And here's the fleet. Again, everything is in YAML. So if you're familiar with YAML, you're familiar with Kubernetes. It's very straightforward. But this is where I configure the game server's desired state. And where the arrow is pointing to with the replicas, I'm telling Kubernetes, at any one time, I want to have 2 replicas running. If my game was really popular, really successful, generating a lot of money, or had a large player base, I could bump that number up. Maybe I want 100 replicas. And then again, you can specify additional configuration options for the resource policy at the bottom. And this is the fleet auto scaler. Again, imagine I've just released my game. It's gone viral. I've got loads of users. I can tell Kubernetes and Agones, this is the minimum size of buffers, the minimum buffer size that I would like, and the max replicas, so that it could be like, think about gaming. Think about the timing that happens with games. Generally in the morning when people are going to school, going to work, your player base is going to be really low. But in the evenings, on holidays, on weekends, you would imagine that your player base is going to scale, right? It's going to spike. So that's where you're not going to waste money, you're not going to waste resources, but again, making it easier for you as a developer, you can say to Kubernetes, the minimum I want is this, but the maximum can be this. So if your player base increases, Kubernetes will scale independently. So some of the benefits is scalability. It dynamically scales the environment and the game servers up or down depending on how many users are there, how many players, sorry. Cost efficiency. Running game servers or running servers in general, we know the cloud, we know data centers is not cheap, so you save money by not over-provisioning. You only use the resources that are needed. Reliability, Kubernetes is extremely reliable, right? If you've worked with it or if you haven't, it will auto-heal. You tell it the desired state declaratively, and Kubernetes will do everything it can to make it work. Obviously, there's issues. It does get complex when it starts to fail, but generally, Kubernetes is highly reliable. And then there's flexibility. DevOps, CI/CD, continuous integration, continuous development, right? Games like products have new versions, they have updates, they have patches, they have fixes. All of this environment can be configured in GitHub, and then you can have a pipeline and do new updates, new releases. You might have version 2 or version 3 of your game. You might want to test new features in a particular part of the world or to specific users. You can deploy another version and target different users. Wow. Feedback. Okay, so the recipe. If you've used Minecraft, it's really fun. It's really great. You can just, like I said, I've lost so much of my life in that game. But essentially, it starts with recipes. You're banging around at the floor, at trees, at rocks, and so forth, and you start to figure out that you can create things within the game world. And these are just some of the examples. But the recipe for the actual, what I'm going to show you with the demo is you deploy the cluster, create the Kubernetes cluster. You can do it locally. You can do it in the cloud. You set the appropriate firewall rules. So the game server and the game components need to be able to talk to themselves within Kubernetes. And then you need the firewall rules for the players to be able to interact with the game server within Kubernetes. So you need all the different firewall rules so that everything can communicate properly, especially with the health checks. You install Agones. Again, very straightforward. You can use something like Helm, or you can do it with Terraform, etc. Have the game server files ready. Have the fleet configuration ready. Run the game. But again, with any kind of product, whether it be a game, a banking application, you want to test it before you do the release. So once you've done all of this, have a nice baseline, a nice steady state, and then you can start making improvements. The moment of truth. Okay, so let's wrap onto the demo. Okay, let's refresh this. Oops. Reconnect. Okay, so this is my Kubernetes cluster. Excuse me. Called it Minetest. Very imaginative name, but it kind of fits the demo. But it's running in Europe North 1A. It's just a standard cluster. It's running in Google Cloud. And if I go to the workloads, outside of the Kubernetes workloads that are used to keep Kubernetes up and running, these are the main components for the purpose of this demo. At the top, we have the Agones. We have the data plane and the control plane. So you have the allocator, the controller, extensions, and ping. The controller is essentially making sure that the Agones system within itself is talking to Kubernetes right and making sure that the game servers are running. The Agones ping is a health check within Agones to make sure that, again, the game servers and Agones are talking to Kubernetes and the environment is stable. We have Minetest, which is my game server, which is managing these two down here. So these two pods are part of this Minetest fleet. And Minetest is like the controller, which is managing those and telling them, hey, I want you to be running in this desired configuration. Make it happen. If I jump into one of the pods, so what you see here is the Minetest. So this is the game server. So when I showed you that complex game architecture, that's all running encapsulated within this pod here. And then the game server sidecar is part of the SDK that you get with Agones. And essentially, it intercepts all the calls into the game pod. Oops. Sorry, that was to make sure I've got enough time for the demo. So it's like a sidecar. And essentially, it runs in combination with the actual game pod. And any network communication that are coming into the game server, whether from Kubernetes or from players, that intercepts them and ensures that, again, for example, thinking about game allocation, it checks to see how many players are running on that game server. If it's overloaded, if it's missed its match, or if it thinks there's going to be latency, it's going to push them onto another game pod. And that's really good. And that's one of the major benefits of using Agones, because it handles all of that for you. So I will show you the game running. So what I have here, I have these two running locally. So if you're on a Mac, you're on a PC, you can install Brew. Again, it's open source, it's free. If you'd like to test this at home, you can always reach out to me on social media, or more importantly, here at the event, and I can talk to you and run you through this demo in a bit more detail. But what I have done, I've exposed my game servers within Kubernetes on this address here. It's running over port 30,000 on UDP. And again, think about the complexity of this, right? I'm dialing in over the internet, connecting to a database within the game server environment, which is managing my user account. Think about a game that you have to pay for, or that you might have to buy updates or fixes or skin packs or something like this. That can be all combined within Kubernetes as a different service as well. So scaling this environment is really easy. This is my user, Jai. I'm going to log in. Hold on. I will. Oh, thank you.
I'm a mic stand now.
Oh, perfect.
It does a better job than me, probably.
Now I do feel like a rapper. Okay. Cool, thank you. Cool. So the reason why I wanted to show you it up and running is, number one, you could run Minetest locally, right? But we're talking about multiplayer games that we want to run across the planet. This is multiplayer, so what I've done, I've kicked off 2 instances of Minetest on my local machine. So I have this user here, Geek Sessions, and what I can actually do, if I register with a new user, so I'll call just this one V2, give it a password. The database within the game world is accepting the new user, so authentication, credentials authentication is all working. And this always happens when I connect, for which I don't know why. I cannot move my face up or down. But I'm in the game world. Oh, I'm in the game world. And there's 2 of us. And to show you that they're both running live, and to show you some of the cool features that I wanted to show you before, if I just quickly refresh here, you can see that I've just logged in with this player. And where is it? PCAP, Jai, and then also, can come in here. I've joined the game. Thinking about developing applications. You need to troubleshoot. Again, it could be latency, where you need to look at the network logs. This gives me the IP address of the user that logged in, so my IP address here, the username, showing you what I was actually doing in the game. So if players start to complain, or they say they have issues with latency, or a feature's not working, you get the logs directly from the game, directly exposed into Google Cloud. But like I said before, you could use any other logging or monitoring tools. You can export these, and then you can do more kind of advanced diagnostics to get better. So, conclusion. Kubernetes, it effectively scales game servers. It's very accessible. It can get complex when you start adding thousands of nodes geographically and so forth, but as an entry point, it's very easy. Agones, it provides Kubernetes a native solution for managing multiplayer games. And Agones and Minetest are open source. And I love open source because it's an enabler, right? Again, money's not abundant. It gives you that access and freedom to try new things, but it makes it easy for you to get into the world of Kubernetes and gaming. And with that, I'd like to say thank you. Do we have time?
Yeah, okay, cool. So you talked about Agones and how it integrates apparently seamlessly with the games and the multiplayer aspect of it. So thinking about me as a game developer, which I'm not really, I played with things like Phaser in JavaScript and some other frameworks. Do I need to do anything specific to make my game compatible with Agones, or is it just a matter of network requests coming in and out of the client and the servers, and Agones just kind of bridges that gap automatically?
Yes, so that's a really good question. There's two ways that you can do it. One, you can just plug the game into the world. Plug the game into Kubernetes and have Agones handle the requests. To get the full functionality, you'd want to develop the game by using the SDK. And again, a couple of lines, you make the game aware, your game code, aware of Agones, and then you'll get additional functionality within that. But it handles both use cases pretty seamlessly.
Hello.
Hi.
Nice speech. I have a question. You said that it scales with pods. It scales with nodes also. And how can we limit the nodes if it scales by region, or can we do that?
Yeah, so there's two ways that you can do that, all configuration as code. But basically, you can tell Agones to handle the auto scaling, and I forget the name that they use, but essentially you can say, if I have the resources, if I have a node that can handle, I think it's bin packing essentially, the bin packing. So I have a node, it may be like, can handle 5 game pods before it will start to fail. You can say, if you get to 4, then start to schedule the game servers or the pods on another node. And that's one way that you can do it. Or you can put resource allocations within the actual configuration file for the fleet and say the maximum on the specific node will be this amount. And then you can do it by memory limits and CPU utilization. But again, because it's Kubernetes native, the bin packing you can use in combination with the auto scaling features within Kubernetes itself. So there's a bit of configuration between the two. And again, like with anything, it's mixing and matching and finding the best use case for your game. It could be that your game can handle low memory limits, but it needs a lot of CPU. So you would do that configuration specific on your game's requirements. Okay. Thank you all, and have a great week.